In this video, we're going to look at modeling as well as solving algebraic equations using these algebraic tiles. So this first example just asks us, which equation does this set of algebra tiles represent? So let's see what we have here. We have x on this side, and we have 1, 2, 3, 4, 5, 6, 7. Just going to write that above, 7. I have 7 there, and we have 1, 2, 3, 4, 5, 6, 7, 8 on this side. So we have x and 7 tiles equals 8 tiles. So I hope you can recognize that this would be the expression that's represented here. X plus 7 tiles is equal to 8 tiles. Something I want you to think about whenever we're looking at algebraic equations is really notice this equal sign, okay? So we're saying 7 plus x is equal to 8. I want you to think of it in terms of a scale. So we're literally saying that the 7 algebraic tiles plus x weighs as much as the 8 algebraic tiles. I'm hoping you guys can solve for x on this and realize that in order for them to be equal, x must equal one more algebraic tile, because 8 algebraic tiles would weigh as much as 8 algebraic tiles. But it's really important to keep this concept in mind, and we'll revisit this later in the video, but they have to be the same on both sides. We can't have our scale heavier on one side than the other. We've established at the beginning that they are equal on both sides of the expression, both sides of the equation. They have to stay equal on both sides of the equation. Another example where we're just writing the equation. Which equation does this set of algebra tiles represent? So over here we have x plus 1, and we're saying that equals or weighs as much, or is this sort of equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 on this side of the equal sign. So that equation is right here. X plus 1 equals 10. This example again asks us, what equation does this set of algebraic tiles represent, or algebra tiles? So we see here, on this side of the equation, we have 4x, and we're saying it equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So simple as 4x equals 12. In terms of solving this, I just want to read what it says underneath here. Combine like terms on each side of the equation. For example, write 3 instead of 1 plus 1 plus 1 plus 1. So we've done that. 4x equals 12 tiles. I'm hoping you can recognize that we can see that, okay, if we have 4x, so each of these x's must represent 3 tiles. So we could say x equals 3. Because if we have each of these is 3, 3, 3, 3, then this side would also equal 12, and we want to say 12 equals 12. This last example says, use the algebra tiles to solve x plus 6 equals 13. So they want to know what x is worth. What is its value? What is it standing in for? What number? So I've taken these images and stuck them on our balance, because in order to figure it out, we need to make sure we remember that they're even, they're equal. So some of you might have already worked ahead and figured out what it must be based on this expression as well as the image, but I want to make it really visual here. So if we're going to keep this even and we want to solve for x, we want to get x by itself and see what x alone is equal to. So in order to do that, I'm going to get rid of these 6 ones. The only important thing to remember is if I take away 6 ones from this side, I also have to take away 6 ones from this side. But why, Miss Cooper? Because if they were equal and weighed the same amount before, and then I just took 6 away from this side, the scale would tip. In order to keep it equal on both sides of the equation, both sides of my scale, if I take 6 away from this side, I have to take 6 away from this side. So now I took those 6 away and 6 away from here. It's really easy to solve this question. X is equal to or balanced with 1, 2, 3, 4, 5, 6, 7. So we can say X equals 7. And we can check it in the expression up here to make sure that makes sense. So our expression is X plus 6 equals 13. We've said X equals 7. 7 plus 6 equals 13. We are correct. I'm really hoping this visual way of taking away the 6 from each side made it obvious to you how we kept that equation balanced. I'm going to show you how we can do it on paper without the visual, although it's the same concept. So we're looking at our scales here. On one side the scale, or one side of the equal sign, we have X plus 6. On the other we have 13. We want to know only what X equals. So we need to get rid of this plus 6. But if we take 6 away from this side, we have to take 6 away from that side as well in order to keep the equation balanced. So I'm going to go minus 6, which is what I did earlier. So now, if you think about it, X plus 6 minus 6 plus 6 and minus 6 cancel each other out. So we end up with just X. But 13 minus 6, that's going to change the number. 13 minus 6 is 7. So just like we ended up with before, we know that X equals 7. That's it for this section. Good luck.